Getting salty with Silsic.
Hey everyone, today I want to talk to you about Limulus polyphemus, the horseshoe crab. And I'm out here on the Indian River Lagoon and I've been walking the shorelines and I found both some molts of the horseshoe crab and a live one to show you. So I want to start with the molt. What we're looking at here is the carapace of a horseshoe crab. And what happens, this is a chitinous material exoskeleton, very hard, very lightweight, but it doesn't grow with the organism like a clamshell or a conch shell or a whelk or something like that, like a member of the mollusca. When they are ready to molt and grow, a seam will split right here, and a soft version of the horseshoe crab will slither out through that crack, leaving this behind. And then it will absorb water, retain water, it will expand. After about a day, its outer skin will harden like this, and then it releases that water that it retained, and then it has some growing room. So let's look at this carapace here and talk about the parts. The first thing that you notice are eyes. This is a compound eye. These are called median eyes right here, another compound eye here. A horseshoe crab has a total of 10 eyes around the body, so it can see in a lot of different directions. It's a member of phylum Arthropoda, and what that means, arthro means jointed, poda means foot or legs. So if you look here, here's one of the legs of a horseshoe crab, and if you look what I'm doing right here, you see that it's jointed. So this is a huge advantage for this group of organisms, which also includes insects. It makes them much more mobile, gives a lot of attachment for muscles, and it's really a great advancement over phylum Mollusca. So anyhow, jointed appendages. You notice the tail right here. This tail is called the telson, and its main purpose is to turn it over. When quite often we find horseshoe crabs in the surf, or with this, not the surf out at the beach, but along the shoreline and more protected areas, and sometimes they can get tumbled and turned upside down, they can use their telson, their tail, to help flip them back over. They can also use it as a rudder. So as they're crawling along the beach or along the bottom, they can twist it this way or that way to help turn them as they are crawling along the bottom. So it's kind of neat how they can do that. This is the abdomen right here, this section here. And this section is called the cephalothorax, head, thorax together. So it's a two-segmented arthropod, where other members like of the insects, like ants, we always think of them having three sections. So the cephalothorax and the abdomen right here. And they have lots of little spines in here to help, protect them. The tail here, they do not use it to, like a stingray does, to impale or as a means of protection or capturing prey. They just mainly move along the bottom. Now this is a pretty small one. If we look right here, we know that this is a male, because if you look at its forward pair of legs here, I often refer to these as they kind of look like boxing gloves. So this is a male adaptation. The females don't have this structure. And I'll show you a female here. You'll notice she's larger, and this is also a molt. And if we look at the first pair of appendages, they're just like that. They don't have those little boxing gloves, so we know it's a female. The male have these structures so they can latch on to the back of the female shell like this, and just allow her to carry him wherever she goes. And then when it is time for reproduction, she will crawl out of the water, deposit her eggs, and he'll fertilize them. And then they'll go back in the water, separate, and go their own way. I have a live one here, so we can take a look at it. Right now he's kind of closed up. This is a male. I'll show you maybe with the other camera some better views of the underside, but we see the cephalothorax, we see the abdomen. Now we can hopefully You can see the legs moving. Now, horseshoe crabs are actually closer related to spiders and scorpions and things like that than they are to actual crabs. And right here in the center, right there, that's where the mouth is. And these appendages, when they find food, they just kind of push them into the structure here, and then it grabs it, and then they can eat it. Oh, also right here, these are called book gills. They're 6 little flaps that they can move, that they can flap back and forth, and that allows for gas exchange, for they can absorb dissolved oxygen out of the water and release carbon dioxide. And they can also move these flaps back and forth, and they can use it to swim. Yes, horseshoe crabs can swim, and when they swim, they typically swim upside down like this. They don't do it for long, of course their tail swim would be back like that. They don't do it for long distances, but they do it for short distances, and then they'll go back on the bottom, and they'll use their tail fin to turn them back around so they can crawl along the bottom. So can you see some of those there? Pretty cool. All right, we'll take another look here at the ventral side of the horseshoe crab. That's another good term. Ventral is kind of the underside, where this is the dorsal side here. Good example there of these book gills. And kind of see how they move up and down. And then right here, oh, here's the mouth. You open into the mouth right there. Can you see it? And then this first pair of legs right there. You can see how they kind of look like boxing gloves. This last pair is kind of interesting. You see they're very different looking. All these are little pincher-like legs at the end. This one's here are more this kind of a structure, and this allows them to push along the bottom, kind of like the tips of ski poles. So they can open that up, increase the surface area, and then push their bodies along the bottom. So here's a little visual of the book gills actually in motion there. You can see them flapping. So a little bit there about the external anatomy of the horseshoe crab, Limulus polyphemus. Thanks for watching.